Spontaneous and stimulated emission is the topic of this lecture. There are actually three important phenomena in the energy band theory and radiation of energy, namely absorption, spontaneous emission, and stimulated. When we talk about optical sources, which are energy sources of light, generating light signal used in optical communication system. In LED, the emission is spontaneous, and in laser, this becomes stimulated and very powerful. So in this lecture, we will try to understand how the stimulated emission is different from spontaneous, and how is the stimulated emission more powerful, having more directivity, narrowed wavelength. We will try to understand. This is an interesting diagram. As I told you, indicating three phenomena. If you look at this side, pumping, second is spontaneous, third is stimulated. We all know that, as you can see, that the molecules, in molecules, the atoms, they always have some energy levels, discrete energy levels, and each and every discrete energy level will have a particular energy value. There may be, if we talk about a molecule or an atom, and when we begin with nucleus, and when we move towards outer and outer orbit, in each orbit, the energy level will change. So what we can see here is the low energy level, and there is upper energy level, lower and upper, high energy, low energy. At both these energy levels or configurations, carriers may be present, charge carriers may be present. So if there is a pumping means there is an excitation, external source of energy, which is provided. When it is provided, the electrons which are there at low energy level, here we also can say ground level, they will get excited, they will get some energy, and when they acquire some energy, it will go up. Why it will go up? Because this side we have upper energy level. This particular phenomenon is called as absorption. Why this is called as absorption? Because the carriers which are here at ground level absorb some energy from outside through pumping, external pumping, supplying energy from outside, absorbs energy and rises up, goes to high energy level. If you see the second part of this diagram, it demonstrates spontaneous emission. And if you see the difference between the first one and the second one, you will find that The electron which is actually there at high energy level, we have also discussed in our previous lecture that the carriers which are always there at high energy level, any carrier cannot reside at high energy level for a long time. After some particular time duration, it will go down. And therefore, you can see that the electron is jumping down, going down to low energy level. And see, when in the absorption process, a carrier moves from low energy level to high energy level, it absorbs the energy, and therefore there is a need of external power, external energy pumping. In the similar manner, if a carrier goes down from high energy level to low energy level, that extra energy with which it was residing at high energy level will be released. And if it is released, that release of energy will be in the form of photon. Photon, which is actually called as, or light as a signal is called as bundle of photons. Bundle of photons. So whenever there is a carrier going down, it will release a photon. Process is called as spontaneous, because this is emitting a photon spontaneously. The moment it goes down, it falls down, spontaneously a photon is emitted, is generated. See the third scenario. Here, if you see stimulated, the photon is generated by this movement from high energy level to low energy level, and this system receives further photons from external light source, external lighting, external supply. What will happen? This photon will sync up with the photon already generated, and there will be strengthening of these process. If more and more carriers are here, that will start accumulating more, and because photons are continuously coming, so those photons will stimulate more and more photons to be emitted. This is called as stimulated effect, stimulated emission. So in this lecture, we will discuss exactly how spontaneous and why stimulated emission take place. This stimulated emission is the main reason why we get a strong beam, a powerful beam of light from the laser output. This is the further description of the same concept. Look at here. This is what is the nucleus, and the carrier is going to the outer orbit. This is in terms of orbit. The previous diagram was in terms of energy level, and I have already told you, when you go from nucleus to outer and outer orbits, the energy level will go up and up. Means the outermost orbit will have highest energy value as with respect to nucleus, right? And then you see here, when you supply an energy, it goes to the next orbit, and in the reverse process, from next orbit to the ground state orbit or towards nucleus, if it is going, it releases some energy. And in the third scenario, if you compare with the previous situation, additional photon is coming, stimulating the effect. So the group of photons ultimately emitted. We can understand the reason for emission from this diagram. You look at atom in excited state, is there. How does it get into the excited state? We supply some energy. Suppose the energy level differences or energy levels are E1 at ground state, E2 is there at excited level. So what is energy difference? Is E2 minus E1. What is energy difference? E2 minus E1. So in either way we can understand both the process. See here, when there is absorption means there is an equivalent photon whose energy is h nu, where nu is the frequency of that photon, frequency of the signal, h nu. This much energy is actually this del E, the difference between E2 minus E2 and E1, E2 minus E1. And that much difference is given to the carrier, which is here, it will go there, or vice versa. If it is here at upper energy level, and if it goes down, that much energy will be released by this process. And this is the third one, it is the stimulation effect, where please understand h nu is always the difference between these two levels, that is the incident photon that has capability to either move an electron from ground state to higher state, or that much energy will be released when the electron comes down, falls down from high energy state to ground energy state. This is also an interesting diagram. I have referred the source from where the image I have used. You see here inner electron. This is the nucleus, and these are representing orbits. The electron is at low energy level when is at nucleus. Electron at high energy level here when it is going to higher energy level. You see here, that is outer and outer orbit. So when the electron goes down, falls down from high energy level to low energy level towards nucleus, then the light is emitted. So this is an interesting phenomenon highlighting about how the light signal is generated. The quantization of energy in the atom results in discrete energy levels is the important process in laser operation. Quantization of energy. Quantization of energy means all energy, all atoms, rather all carriers, they always have some discrete value of energy, and therefore they are quantized. Quantized means there are discrete values of energy for the carriers, for the electrons, and based on the groups, there is one layer where there are carriers whose discrete energy value level is same, so that will form a group. In a band theory, we call conduction band, valence band, forbidden band. So in conduction band, there is a band. That band is actually, a range of energy values, a range of energy, that is discrete energy values, where the almost similar or almost same values of energies are there in those carriers. The transition from one energy level to another always causes light emission, provided when it moves from high energy level to low energy level. If it moves up from lower to higher, energy will be required, and when it falls down from higher to lower, energy will be released, and the energy which will be released is in the form of light, bundle of photons. The transitions include spontaneous and stimulated. The transition may be of spontaneous and stimulated type. Let us see spontaneous. Spontaneous emission where an isolated atom is excited into high energy state. We have seen an isolated atom is first of all excited into high energy state that remains in excited state for small duration before emitting a photon and making a transition into low energy level. So when there is an excitation, an isolated atom is ground state goes up at high energy level, but it will not remain for a long time there. At high energy level, generally the carriers do not remain for a long time. For very short duration of time, for very small duration of time, it will reside, it will remain there, and then it will fall down. While falling down, it will release energy. That transition will release energy. This process is called as spontaneous emission. The emission of photon is probabilistic event, and its probability of occurrence is described by probability per unit time. It varies. It's not like that there is a continuity. There is a probability of occurring the emission. So for many excited state of atoms, average time before the spontaneous emission of photon is generally 10 to the power 9 to 10 to the power minus 8 seconds. You can imagine it's almost nanosecond. 1 nanosecond or 10 nanosecond. 1 to 10 nanosecond is the time duration where there is a transition when exactly spontaneous emission happens. Look at here. This is what we have seen. There is an electron at E2 and there is ground state low energy level where the electron is falling down, releasing a photon in random direction. That is another interesting thing. That is a difference between stimulated and spontaneous emission. In spontaneous, the photons which will be generated will have random direction, will not sync up, will not have same phase, same frequency, same length, same direction. They will be emitted in different directions. More and more photons are generated, emitted. All those photons will have random direction. So let us see stimulated now. In stimulated emission, as I have told you, the electrons are randomly distributed between two levels. We already have discussed, and those two levels are two energy levels. And therefore, the electrons undergo transitions from one level to other, either by, there are two phenomena, absorption or emission. Either it can absorb and go up, or it can fall down and release some energy. Lower level electrons can only absorb light by, that process is also called a stimulated absorption, because there is a stimulation. Something is stimulating, some external source. So energy is absorbed and then the carrier goes up at higher energy level so that it reaches to upper level. Once an electron resides in upper level, it can either, now electron has reached to higher level. So there are two possibilities. It can either emit a light wave and drop to low level, low energy level. It will emit a light and then release some energy and then will go to low energy level called as spontaneous emission. Or it can be stimulated by light wave. It can be stimulated by light wave, actually falling down, photon is emitted. Now the same carrier is stimulated by another photon, stimulated by light wave, which is actually photon, bundle of photons or photon, to emit a second wave. Already one wave is generated while falling down. Now the same carrier is emitted by one incoming wave, light wave, and then finally that that carrier will go to lower level. So while traveling, it gets stimulated. There is one more photon which is emitted, and that syncs up with already emitted photon. So you see here there are two waves now. So there is a strengthening of wave in this emission. And please understand, the direction is same in the stimulated case. This is, we have already discussed this diagram, and we can understand how in the third case you can see the stimulation is taking place. The photon which is coming as the input photon, this is common in all the three diagrams. This stimulates the falling carrier, this electron, and after stimulating again it generates a photon, and then it has to settle down. It reaches in ground state, but what is the outcome? As a result, we have obtained now two waves in same direction. When we have hundreds of such waves, and those waves are confined in certain cylindrical or spherical tube-like structure, that is what we see in a laser. It becomes powerful light beam. So if an atom or molecule lies in an energy state that is higher than lowest is called as ground state, it can spontaneously drop to low level without any outside stimulation. Suppose there is no stimulation at all, but there is some electron which is at higher energy level. When it drops down, spontaneously it will drop down to low energy level. The outcome of dropping of reduced energy state will release the excess energy. Why there is excess energy? Ground state E1, upper state E2. What is difference? E2 minus E1. So that is the excess energy with which the carrier was residing there. So that excess energy will be obviously released in the form of photon. Spontaneously. Excited atoms or molecules have spontaneous emission time, which is average time during which they remain in the excited higher energy state before dropping to low energy level. They have some average time to stay there. After that, they cannot stay and they have to fall down. So this emission time is an important factor, please understand, in producing the stimulated emission. While in the excited state, the atom is illuminated with an incoming photon. Now suppose it is already in excited state. Now it gets illuminated further from outside. There is no illumination, it's spontaneous. There is illumination means some more photons are coming. So that will stimulate the photon. And this photon, please remember, having same energy, same phase with what is there at the high energy level. So this atom may be stimulated by the photon, by the incoming photon, and then it will return to the low state, and this particular emission, the transition will emit the carrier, emit the photons. A single photon interacting with an excited atom can result in two photons. Why? If one photon comes down, falls down, it will, one electron falls down to low energy level, one photon is generated, emitted. But there is one more photon from external source. It is stimulating the electron which is already there at high energy level. So that will also stimulate another photon to emit. So there are now two photons which are emitted rather than single photon. This is unlike spontaneous. In spontaneous, there is no supply from outside externally. So if the emitted photons are seen as wave, the stimulated emission will oscillate at incoming light frequency and phase. Suppose this photon is considered as a signal, as a wave, light wave. So if it is a wave, it will have certain frequency, certain phase. So that phase and frequency will be same with what incoming photon had. And all those photons therefore will have same frequency, same phase. So they will be synchronized, and they will be all, they will constitute a beam like called as coherent beam. This is the outcome, and that outcome then it goes in amplification of original light wave intensity. So this is how, if one wave is there, more and more waves are added up, and this sum of all the waves results an amplified version of light, which we generally call it as a light beam with higher intensity. So we get a powerful beam in case of stimulated emission as compared to spontaneous. So if we can understand with another interesting diagram, see here spontaneous emission decay, right? Before upper level, lower level, a photon is generated, and after see one photon is generated in spontaneous. Now there is no supply. In stimulated, already there is one photon at upper level. Now the stimulation is coming from external photon. So this will stimulate this. So it will generate two photons because one due to this already coming down, and one because of a stimulation effect of photon to this carrier. So we have two photons generated. And stimulated absorption, we have already discussed. There are three phenomena actually. Stimulated emission is stimulation is there from outside, but the carrier was at low level, so it goes up. So there are three phenomena. Let us sum up. First, when carrier is originally at high energy level, falls down, releases energy, spontaneous emission. Carriers are at high energy level, but there is continuity of the stimulation coming from external source. It will stimulate the carriers and will emit more number of photons. Stimulated emission. Third, stimulated absorption, where stimulation of photon from external sources there, but the carriers are initially, the electrons are initially at low energy level. So that will go up. Stimulated absorption. I have included the source from where it has been taken. We are mainly focusing on stimulated. The mechanism by which the stimulated emission dominates, as I told you, there is a dominance of stimulation effect, because more and more atoms or carriers rather which are there in excited state, they are falling down to low energy level. That causes emission of more and more number of photons. So the emitted photons are more likely to stimulate emissions than to be absorbed. The excited photons which are there, and those excited electrons rather, carriers, they emit the photons, will get stimulated rather than absorbed. They will get stimulated. They are already at excited state. And there is continuous stimulation from outside coming in the form of photons. So this condition is inverse of normal equilibrium situation called as population inversion. As its name suggests, very simple. At high energy level, there are many carriers. Now they are finally reaching to ground state. At ground state, number of carriers will increase. At higher state, number of carriers will decrease. So wherever there was population, wherever there is whatever value of population will get inversed, reversed. Wherever it was high, will become low. Wherever it was low, there it will become high. This phenomenon is also called as population inversion, which is an important phenomenon in this emission. So as long as there are more atoms in upper energy level than in lower, the stimulated emission dominates, and a cascade of photon emission. That is very important. We have to understand. More number of atoms, or rather, the electrons are there in the excited state as compared to ground state. So that will stimulate more stronger effect. So a cascade of photons, there will be cascading effect. The carriers are coming, but stimulation by photon from external source is stimulating more and more number of photons to be generated. More and more photons are getting emitted. So there is a cascade effect, and therefore we'll get a number of waves coming together in the output of that mechanism where we are getting stimulated emission, and those waves will, because all they are coherent, synchronous, in phase, same frequency, they will be added up, we'll get a stronger wave as a bundle of photons, as a form of beam of light, that is light beam. The first emitted photon will stimulate the emission more that of more photons, and subsequently stimulated the emission more and more and more. The meaning is, when the first emitted photon, that will emit some number of photons, but the stimulation is continuing. So what will happen? The stimulation goes on, and therefore now more and more photons will get stimulated, and subsequently more and more photons will get emitted. This is called as cascading effect. The photons are accumulated in a cumulative manner. This is the effect called as cascading, and this cascading grows as the stimulation effect is more from external light source or energy source. That results the amplified version of emitted light. I've already explained. It looks like the higher intensity light wave. It's mainly due to there is a bundle of photons, there is a cascading effect, more and more photons, but what is more important is all those photons have same frequency, same phase, therefore they are synchronized, coherent. So the stimulated, I can put the image here. In stimulated emission, the presence of photons with appropriate energy triggers an atom in an excited state to emit a photon of identical energy to make a transition to low energy. Identical energy is more important. The energy which is emitted, the energy which is generated is identical. Identical in the sense, frequency, phase are all same, but they're all adding up. As with absorption, the probability of stimulated emission is proportional to intensity of light bathing the atom. It means more is the probability of stimulated emission, larger or brighter will be the intensity. More will be the intensity of light. So the brightness, the intensity of light will be determined by what is the probability of stimulated emission. Probability is more with the absorption, stronger intensity value of light. That light with larger intensity as a brighter light will be emitted. The emitted photon is identical in every aspect to stimulated photon. Already explained why identical. Identical is due to same energy, same polarization as well, and it also travels in same direction and same phase. Same phase, same polarization effect, same direction, same energy level. Therefore, that is identical. So stimulated emission is highly monochromatic generally. This is what we have studied in laser as an optical source. Stimulated emission is highly monochromatic. It emits a stronger beam, which is bundle of photons, bunch of photons. All small waves have been added together. But since the wavelength, since the frequency and phase is same in all these small waves, and that's common in the resulting wave, therefore we can say constructively all have been added up. So the wavelength which is finally seen as an outcome is monochromatic. It has particular wavelength. It is a particular light color, and it is directional as well, with having, that is, it has a very good value of directivity. Focused beam, therefore, we see the narrowed wavelength and narrowed beam, narrowed, stronger and powerful beam in the output of laser. It's because of this reason. And coherent, of course, coherent. This is why it became monochromatic and directional as well. Coherent means all the small light waves, their all frequencies are same and they combine together with common frequency. So there are many modern applications, methods, techniques, laboratory equipments and experimentations where this kind of beam is needed for studying various chemical reactions and other things in order to probe atomic and molecular structures and dynamics and their dynamics. Molecular structures in chemical reactions and their dynamics. We need a very sharp, a very narrowed beam that can strike with a molecule and we can understand and interpret the behavior of that molecule. Of course, the stimulated emission is also used in numerous technological applications. One of the prominent applications is a laser, which is used as a powerful optical source in optical communication system. So let us sum up now this lecture, which is about spontaneous and stimulated emission. There are three phenomena called as stimulated absorption, spontaneous emission, and stimulated emission. So we have discussed with the help of nice and interesting energy diagrams, energy levels, concept of energy levels and energy diagrams. In stimulated absorption, there is a photon coming from outside externally, and that will stimulate the carriers or atoms which are there at ground level, and they will move to higher level, higher energy level. In the second scenario, if there is some carrier, or even if that carrier due to absorption which has attained to high energy level, it cannot remain there for longer time, so it has to fall down. When it falls down, will release energy. That energy will be equivalent to the difference between the two energy levels. We know that He2 minus E1 energy difference is equal to h nu. H is Planck's constant and nu is the frequency of that wave which will be emitted. So that emission will be of photon. And in the stimulated emission, third one, what we have seen, that in the excited state or higher state, atoms are there. Those atoms will fall down, will definitely emit the photons, but they are getting stimulated by external photons at the same time. So that stimulation effect will increase the number of photons which will be ultimately emitted by the system. And when that stimulation increases from the input to all the excited atoms which are there in excited state, the effect becomes cascading effect, and all those photons which are having same frequency phase energy value, they all are added up, and we get a powerful narrowed wavelength beam, a coherent signal, which we call as a light beam and a powerful beam. So the stimulated emission is very powerful. It is used to generate a powerful light beam, and therefore this stimulated effect, especially used in a lot of experimental laboratory investigations where the molecular structure and other structures are studied with the help of a pointed and narrowed powerful beam. In a number of technological, printing and other applications, light, wherever the light source is needed, like an optical communication system, laser is there where the stimulated emission is also required. So that's all for this lecture. Thank you.